Hey there, physics students. Welcome to another edition of Rapid Review for Honors Physics. Today our topic is waves. Okay, now when you think of waves, you might be thinking of the waves on water or other kinds of waves. We're going to focus on a definition of wave that is just transmission of energy over a distance. In fact, much of what we do is going to be in one dimension. Let me use an example of one-dimensional motion of a wave. I'm going to take this rope and I'm going to try to send energy down along the length of the rope. I'm going to do it by giving it a jiggle on one end, and I'm sending a pulse of energy down the line. Let me do that one more time. And you can see my pulse travel to the end. Now in the middle, I have a little piece of a marker here, and the point of this is to show you that even though the wave is moving that way at some speed, a little piece of the wave that I'm showing here is not moving that way at some speed. It's just moving up and down, I'll have you notice, pretty much. Okay, so that is the difference between wave speed and the motion of an individual piece of the wave that makes up the medium. Oh, I said the medium. Remember that the medium is the material that the wave travels through. So these are mechanical waves. By the way, there are other kinds. We won't talk about them here in this presentation. Mechanical waves require a medium, and it's just the material that carries the wave. In this case, it was the rope, and that's probably all we really need to even think about for the rope right now. I did send a pulse. I could have done a periodic motion, maybe move it up and down repeatedly with a repeating pattern, right? You guys remember that word from when we studied simple harmonic motion. It is the same notion. It's a repeating pattern. I made a nice face there. I like that. Sunglasses? Yeah. That's pretty pleasing. All right, let's keep this moving right along here. I would like to do more demos here. I have to interject with a disclaimer. This topic and the next couple I will talk about really benefit from demonstrations, visualizations, practice on your part, labs on your part with real physical objects, and just general messing around with real physical objects. So I'm going to not do as many demonstrations as I really wish I could, partly because this is a review and partly because I'm not in a physics classroom with a really awesome closet full of toys. So let's accept that, and with my advance apology, I'll go through quickly some of the knowledge that you need when you do go back to messing around in the classroom. Okay, we looked a minute ago at a transverse wave because we noticed the medium was moving perpendicular to the direction of the wave. There's also longitudinal waves where the pieces of the medium move in the same direction as the wave travel. So you might see in a video, which I will link, you might see the difference between a longitudinal wave, which was initiated by moving a hand back and forth, left to right, and a transverse wave, which is similar to what I did, moving the medium up and down to initiate the wave. Okay? So the speed that the wave travels is the wave velocity, and its magnitude, of course, is the wave speed, right, if you just take the magnitude part. But the real thing about this is that the wave velocity and the pieces of the medium motion are not the same. In fact, it's the very definition of a longitudinal versus a transverse. If you observe that pieces of the medium are moving left to right as the wave travels down the medium, you're looking at a longitudinal wave. And if you notice that pieces of the medium are moving up and down as the wave travels along the medium, you're looking at a transverse wave. In both of these pictures, the wave is moving left to right from your perspective as you look at the slide. Okay? So you can even estimate the speed of that wave if you just assume some length, which was not given in the video, you can just calculate the wave. It's how far it went divided by how much time it took, right? So classic definition of wave speed, it's like any other speed, change in position over change in time. A reflection will happen when the wave gets to the end. In my rope experiment, I did an upgoing pulse. If we could see its reflection, it would be coming back as a downgoing pulse. It gets reversed in its direction. That was difficult to demonstrate with my system because I have a lot of damping in my system. So let's see. Yeah, if two waves meet, two waves come into each other, say there's my pulse and the other pulse, as they meet, they will add to each other. We've learned, right, that is superposition, where one wave adds to the other. If one wave's coming this way and the other wave is coming this way, when they get together, they'll cancel as they pass each other, and then they'll continue on their way in the same orientation that they started. That was a terrible way of showing you. If you want to see a really good way of visualizing interference, constructive interference and destructive interference, I highly recommend that you check out the video that I link by, it's a series called Flipping Physics. It is actually my favorite series in the, among physics videos, and you will see in that video a really nice slow motion video of two waves, pulse waves, hitting each other and what happens if they're in the same orientation versus the opposite orientation. I will link to that. Highly encourage you to watch that video. When you practice on your own, I encourage you to watch out for the elastic limit of springs. Elastic limit is what happens when you stretch a spring too far. So if you're taking good care of your lab equipment, you'll want to be careful about stretching your spring too far. This happens with any kind of metal. You could try it out with a paper clip. It'll bend and it'll spring back to where you want it up to a point. And then you reach an elastic limit and your paper clip doesn't function as well anymore as a paper clip. I think that's mostly what I wanted to talk about. I think I'm going to stop there, send you off to watch the Flipping Physics video, and if you have any access to springs or even ropes like I had, you can practice making pulse waves or other kinds of waves. We're going to talk more about that in our next episode, so I hope you'll join me for that.